Example 1. Identify the conic that each polar equation represents and also give the position of the directrix. So now guys, on example 1, example 2, they're related. On your homework, I would totally combine these two set of instructions, okay? So I'm just going to lecture these two set of examples as I would on a test. So let's see if I can start with 1A. 1A says identify the conic. So we need to know what the value of E is. And so let's start with the standard form. It is sine, so the standard form, it's going to be R equals E times P all over 1. And it is minus sine of theta, so I want to do minus E times sine of theta. Well, as you can see, there's 1 minus sine of theta, so immediately I know that E has to be 1. Now, if E equals 1, the shape would be the parabola. Okay, so box that up because it's asking for identifying the conic. Now, in addition, it said, okay, well, give me the position of the directrix. That means, hey, what is the value of P? Well, on the numerator, we see is 3, and that is going to be E times P. So 3 equals E times P. We know E equals 1, so P equals 3. Well, it is a negative sign value, so we have to say that the directrix, it's parallel to the polar axis and is 3 units below the pole. And it is 3 units below the pole. Okay, so that's the information about the conic and the directrix. On number 2, we'll go further to where we would be graphing it, okay? Let's try B. Example 1B, again, let's start with the standard form. It is cosine, so standard form, R equals E times P divided by 1 minus E times cosine of theta. Well, if you look at this right here, that's not 1 minus, so we have to, for it to be in standard form, we have to get rid of that to make sure it equals to 1. So what we want to do is we are going to take 8 minus 2 cosine of theta to make that first value 1. We are going to multiply each and every term by an eighth. Well, what we multiply to the denominator, we would multiply to the top. So the original value is 1 multiplied by 1/8, just like that. All right, so this will give us R equals, on the numerator is now 1/8. On the denominator, that will give me 1 minus 2 times an eighth is now 1/4. And then cosine of theta. Okay, well that will give us an E value right away. This E value is going to be 1/4 because it's in standard form. E value is just in front of the cosine or sine. So let's see, E equals 1/4. If it's 1/4, it's less than 1. So if it's less than 1, it is an ellipse. So we identify the conic. Okay, so that's definitely an ellipse. Now we need to find the p-value. On the numerator, it's 1/8. And the numerator is always E times P. Well, E is 1/4. So we fill in 1/4 times P. Now we just have to solve for P by multiplying both sides by 4. So P comes out to be 1/2. Well, P is 1/2, and it's a negative, excuse me, it's a negative 2 cosine. So what we want to state is the directrix. You know what? Let me go to the right. Directrix is perpendicular to the polar axis and is a negative cosine. So what we want to do is we want to say it's 1/2 units and directrix perpendicular to the polar axis and 1/2 unit to the left of the pole. box that up. All right, so that's example 1 right there. So example 1 is pretty basic. Tell me the E value. Once you know the E value, you should be able to state the conic. Then find the P value. If it's negative sign, then it's below the pole. If it's positive sign, then it's above. If it's cosine, if it's negative, then it's to the left. It's positive cosine is to the right. Okay, so example 1 is pretty basic. Now example 2, you would still need to know example 1, but now we're adding on a lot more, such as graphing it. And to graph it, since you won't be able to have a calculator for these type of questions, you have to convert it back out to rectangular. And I hope you guys remember that from the last unit. Okay, let's again try to find E to see the conic, what type of conic, and then we can graph out the directrix right away. So let's start standard form. It is a sine value, so we want to go R equals E times P all over 1 plus E times sine of theta. Well, as you can see here, this is not a 1, so just like earlier, we want to go and multiply each and every term by a fifth. R equals 5 plus 4 times sine of theta. Multiply this by a fifth. Now what you multiply to the denominator, you're going to multiply to the numerator, just like that. This will give us, on the bottom, 1 plus 4/5 sine of theta. And on the numerator, it will give us 12 over 5. Leave it just like that. So this will say, okay, E is 4/5. That is less than 1. If it's less than 1, it is an ellipse. So at least we know that we will be graphing an ellipse. Now on the numerator is 12 divided by 5. So 12 divided by 5 equals E times P. We know E is 4/5. We can fill that in. Times P. Now we do want to solve for P, so I do want to get rid of 4/5 and multiply both sides by its reciprocal, just like that. So P is going to come out to be, cancel the denominator. P 12 divided by 4 is 3. So P is 3, and it is sine, and it's positive sign. So what I know right now, let's plot it, okay? What I know right now is the directrix is 3 units above the pole. So we know it's the directrix here. If we know the directrix is above the pole, I also know this ellipse is going to be vertical. That means the major axis is going to be parallel to the y-axis. Okay. Now, since you won't have a calculator, you're going to need to graph this by hand. And to do so, we need to convert it to rectangular form. To convert it to rectangular form, we will make this into a fraction and cross multiply. Okay. So when we cross multiply, we get R times 5 plus 4 times sine of theta equals 12. This is 5R plus 4R sine of theta equals 12. Well, R is the square root of x squared plus y squared. Now, R sine of theta is just simply y. Next, we want to complete the square, but first we have to get rid of the radical. To get rid of the radical, we are going to move the 4y to the right side and then square everything. Just like that. That will allow us to get 25 times x squared plus y squared equals 12 squared is 144. Don't forget you have to FOIL. This is going to be 16y squared. In the middle, you're going to have 2 times 12 times 4. Well, 4 times 12 is 48, and you have 2 of those. That's going to be a negative 96y. Oops, I missed a parentheses. Distribute your 25 out. So you're going to have 25x squared plus 25y squared. On the right side, just drop everything else back down. Okay, just like that. Now let's see if we can complete this square. To complete the square, move 16y squared over. 16y squared. At the same time, I'm just going to move the 96, negative 96 over as well. So we will have 25x squared. 25y squared take away 25y squared take away 16y squared is now positive 9y squared. I'm moving over 96y, so it's now positive here on this side. Leave a blank space for us to complete the square. We would only need to complete this square for the y. Okay, so 25x squared. We can't have a leading coefficient, so we have to factor that out. Take out a 9, so that's y squared plus 96 over 9 times y plus a blank space. 96 over 9, we can reduce that a little bit. So let's reduce. All right, so let's see, divide both sides, both top and bottom by 3. That would give us 32 all over 3. Y plus a blank space equals 144. Okay, now here's the side work. We want to take half of 32 over 3. Half of 32 over 3. So half means we will take 32 over 3 times a half, which is 32 over 6, which we can reduce that down to 16 over 3. There you go. So that's half. Now I have to square it. Once you've done the half, you got to square it, okay? So 16 squared, it's 256 over 9. And that's what we're going to fill in right here. 256 over 9. Now what you're adding to the left side, we got to go and add it to the right side. But this is being multiplied to 9, so don't forget we multiply that by 9. All right, so now let's do, I'm out of space on the bottom. I'm just going to go, let me pinch it in to see where I would be going. Let's go right here. Okay, so here we go. We got 25x squared plus 9 in the front. We can factor that out, so we're going to get y. And the reason I love having the half still somewhere on my scratch work, because when you guys factor it out, that's going to be super useful, okay? So when you guys factor that out, that's just simply y plus whatever that half, oops, there's 16 over 3. 16 over 3 squared. And then over here, the 9s and the 9s will cancel. 144 plus 256 is exactly 400, just like that. Okay, as you know already, the ellipse has to equal to 0, so now we have to divide each and every term by 400. So that will give us x squared over, sorry, I need more space, so I'm trying to fit it all in. X squared over 25 over 400, that's going to be reduced down to 16. And then 9 and 400, not much you can do there. This is 16 over 3 quantity squared, and I'm going to leave 400 over 9, just like that for now, equals 1. So guys, this is my standard form of the ellipse. That will help me identify the center to plot and see if the directrix is going to be where it's supposed to be, okay? So center is 0, negative 16 over 3. Negative 16 over 3 is an equivalent to negative 5 1/3. You can give me either format. So let's plot it right away. We're going to plot as we go along, if that's okay with you. I do need tick marks, so 1, 2, okay, so dot number 1, negative 1, 2, 3, 4, 5, 5 1/3, so super close to that negative 5. Next, I do want to find a square, because if I have a square, I would have a. If I have b square, I would have b, right? All right, so 400 divided by 9, it's a lot bigger than 16, so that would be a squared. A squared equals 400 over 9. Then a is going to come out to be 20 divided by 3, okay? That, if you want it into mix, that's 6 2/3. Now, I can go and plot the vertex right away, okay? Vertice 1 and vertice 2. To get the vertices, all I have to do is add 6 2/3 or minus 6 2/3 to the y coordinate of the center. Okay, so if I add 6 2/3 to -5 1/3, I would have 1 1/3. So let's go up to positive 1 1/3, somewhere right there, vertex 1. Okay, and then I can subtract. So -5 1/3 minus 6 2/3, that will give me exactly -12, which is all the way down here. All right, so I got my two vertices. Let's go and plot my minor. B squared equals 16. That means B is going to be 4. So I need to mark 1, 2, 3, 4. 1, 2, 3, 4. So from the center, I'm going to go 4, whoops, 4, and 4. That is enough for me to sketch out my graph. Just like that. Okay, so as you can see, it is correlated to the directrix that we graph from our polar form. So what does it mean for us to analyze the graph? For us to analyze the graph, I'm looking for the center, the two vertices, okay, and the two foci. And the shape of the conic, which is in this case an ellipse, and p-value. All right, so, and as you can see, the shape of the ellipse, the p-value is very similar to example 1. So that's why I said example 1 and example 2 are super related. So now let's just state the vertices. All right, y'all. Vertex 1 is going to be 0, 1, and, I'm sorry, not negative, 1 1/3. Vertex 2, 0, -12, foci number 1, foci number 2, and all the x coordinates are 0. All right, so I need to find C if I need the foci. We have a squared, we have b squared. Then from there, we know that a squared equals b squared plus c squared. A squared is going to be 400 over 9. B squared is 16. All we got to do is find C. Okay, so now we need to subtract 16 from both sides. If we subtract 16 from both sides, we would end up with, if I can write 256 all over 9 equals C squared. Take the square root, so that's going to give us the square root of 256. I think I did something like this earlier, didn't I? 256, that number seems, oh yeah, right there. Whoa, so the square root of that is 16 over 3. Awesome. 16 over 3. That's your C value. So if we have the C value, we can add that to our center or minus that from the center. Now, if you want to make that into a mixed number, that's totally okay too. 3 times 5 is 15, so we know it's 5. And then we have 15 is 1 of it is left over. So C is 5 1/3. So if we add it to the center, we would take this, whoops, why is not writing? If we take that, add a C value, what is 0? Yeah, remember the definition? Where the focus is at the pole? Totally, that's one of them, okay? And then the other focus is going to be minus that from the center, so it's going to be -10 2/3. All right, so box this up, because that's what I want. Box up the center. Those are the information that we're going to be asking. We already talked about the ellipse and the p-value, all right? Okay, I'm out of space, but I wanted to show you that you can also graph this one using polar. Okay, so in polar, we pick an angle, we try to calculate the radius. The equation was, let's get the equation in polar. That was 12, let me copy it down. R equals 12 divided by 5 plus 4 sine of theta. All right, so that's your polar equation, and we want to see if it matches our graph that was done in rectangular. We will pick 0, pi over 2, pi, 3 pi over 2. We don't need to do 2 pi because that would just bring us back to the 0, all right? All right, let's do it. When sine is 0, that's definitely 0. 0 times 4, that's going to be just straight up 0. So now it's going to be 12 over 5. So if you want to make this into mixed number, that's okay too. That should be 2. 2 times 5 is 10 with the remainder of 2. So 2 and 2/5. Okay, now if you look at our graph, at the angle 0, which is the polar axis, it's not exactly 2 and 2/5, but you know it's right about there. It's in between 2 and 3. So we're on the right track. Now let's see what happens when we plug in pi over 2, okay? And there you go. So pi over 2 is 1. 1 times 4 is 4. And then so now we got 12. 4 plus 5 is 9. Let's reduce that down to divide top and bottom by 3. So that's going to be 4 over 3. And that's exactly 1 and 1/3. Okay, let's see what happens. Let's go to pi over 2, which is this angle. Whoa, it's 1 and 1/3, just like that vertex that we calculated in rectangular. Let's go do pi. Sine of pi is 0, so this is now back to exactly 12 divided by 5, which is now that's 2 and 2 over 5. Well, what? That's the same value over here at this angle at pi? Yes, it is. Totally. So if you think that, if it doesn't say, if the instruction does not instruct you to graph it in rectangular, or you have to graph it in polar, you can graph it any way you want. So again, let's go do sine of 3 pi over 2, which is -1. -1 times 4 is now -4. 5 plus -4 is now 1 in the bottom. So 12 divided by 1 is 12. At 3 pi over 2, did we get 12? Yeah, we went all the way down. Look at that. So check on that box. So as you can see, if you can graph it in polar and that's a lot quicker for you, feel free to do so. All right, guys, so let's analyze in graph 2b. R equals 3 cosecant of theta divided by cosecant of theta minus 1. It doesn't look like any of the standard form that I've given you in polar format. So what we want to do is convert it all out to either sine or cosine to see what this looks like. So R equals cosecant, so 3 times 1 over sine of theta, because cosecant is 1 over sine of theta. Then again, 1 over sine of theta minus 1. Now we want to get rid of fractions, because currently we have fractions over fractions. So we want to multiply this by sine of theta. What we multiply to the top, we multiply to the bottom. All right. And let's see what this turns out to be. This is now R equals, cancel and cancel. We would have 3 on the numerator. Then this is going to be sine times 1 over sine is now 1 minus, and 1 times sine is just sine of theta. Now it looks a lot better than what originally the equation was. Okay, so now we got R equals 3 over 1 minus sine of theta. Okay, so let's find E. E equals, because this sine has a leading coefficient of 1, so E equals 1. Then on the numerator is 3. So on the numerator is E times P equals 3. Now E is 1, so 1P equals 3. So P is just going to come out to be 3. Now since E equals 1, we know the shape of this conic is going to be a parabola. Box that up. Now it's a sine function, and P is 3, so it's a negative sine function. So this tells me the directrix is parallel to the polar axis 3 units below the pole. Now this will help me kind of check my rectangular work a little bit. So I'm going to go in and plot some points here. 1, 2, and 3. So here is my directrix. We know it is a parabola. Now for the polar, we know the focus must be at the pole. So focus, it's at the pole. So we know it is immediately 0, 0, okay, in rectangular coordinates. So box this up right here. And so what we want to do is we want to check it. We want to check to see if that's true. So what we want to do is I'm going to get a different pen and convert your polar equation here into rectangular to see what we can do from here. Alrighty. Oh, I might want to get back to a pen instead of highlighter. Okay, cross multiply. So we are going to end up with r minus r sine of theta equals 3. And you guys already know r is the square root of x squared plus y squared minus y equals to 3. We want to get rid of the square root and then complete the square, but I do have to move the y over. So right now it's square root of x squared plus y squared, and then move the y over to give us 3 plus y. Now go ahead and square both sides. This is now x squared plus y squared equals, don't forget to distribute this correctly. That's going to give us a 9 here and a y squared here, but in the middle you would have 2 of 3 times y, so that's 6y. Now let's move the y squared over, but if I move the y squared over, that's completely gone, which is perfectly okay. Perfectly okay to have that gone. Now if you guys remember, this is a parabola because only one of the variables is square, okay? Okay, we don't have to complete the square here because x, we don't have any other x term, but we do want to write this in order so we can put it in the standard form of our parabola. So let's factor out the 6. If we factor out the 6, we would get a 9 over 6, which we can reduce that down to 3 over 2, just like that. All right. Now this is the standard form of the parabola. That would give us the vertex immediately. Vertex would be h comma k. Well, the x squared doesn't have any value, so that would be immediately 0. And the k value is negative 3 over 2. Box that up and plot it right away. So 0, negative 1.5. Just like that. Perfect, right? Now let's go and see if we can find our lattice rectum so we can finish the graphing. Now this is graphing using rectangular. I will also show you how to graph it in polar coordinates, okay? You can graph it either way, it doesn't really matter. It depends on what I'm asking you. If I'm asking you to give me the vertex, focus is always at the pole, so that's always easy at 0, 0 for the parabola. Or if I give you, hey, you know what, why don't you guys go from polar to rectangular, then you have to do this. But if it doesn't say anything like that, then you can graph it however you like. So we do have the lattice rectum, which is an absolute value of 4a. Well, 4a happened to be 6. Okay, so 4a happened to be 6. So let's solve for a. 6 over 4, which is going to be 3 over 2. All right. Okay, guys, so now a is 3 over 2, which completely confirms what we already know. We know the a distance, y'all, is from the vertex to the directrix, and that's 1.5. Also, a is from the focus, remember, to the vertex, to the vertex, but we know the focus is right at the pole, so that is, we're on the right track. We know all of that is working together so nicely. Now, lattice rectum is the distance, which is 4a, which we know is 6, okay? Now, from the focus, we will go 3 units to the right and 3 units to the left to make 6. Just like that. Make your dots. And then connect that with your vertex. Opens upward. Okay, there's the parabola. Now, what would that be if I said, just graph it in polar? It's even easier. Okay, polar, let's go back to the polar equation, which is r equals 3 times 1 minus sine of theta. All you gotta do, find an angle, find the radius. We will start at 0. when theta is 0, sine of 0 is 0, right? 1 minus 0, and the denominator is 1, so 3 divided by 1 is 3. Bam. Check. Let's go to pi over 2. Sine of pi over 2 is 1. 1 minus 1 in the denominator is 0. 3 divided by 0. Not possible right now. All right, let's go to pi. Sine of pi is going to be 0, 1 minus 0, and the denominator is 1. 3 divided by 1 is, again, 3. Bam, check. Let's go to 3 pi over 2. All right, sine of 3 pi over 2 is negative 1, and 1 minus a negative 1 in the bottom is now 2. On the top, we have 3. That's 1.5. What? We have a dot at 1.5? Of course we do. So, guys, we can see that either way, whether you guys are graphing in polar or rectangular, we should always get the same exact graph. All right, now the only thing left that I want to add for this example is if I were to ask you guys to label everything in polar coordinates, then the vertex would just be, we know the radius is 1.5, aka 3 over 2, right? So we can do 3 over 2, comma 3 pi over 2. That would be polar format, okay? So this is polar. And then over here is rectangular. Okay, this is rectangular. So depends on the instruction. Since this one doesn't say, you can label it either way. All right, y'all? Example 3, convert each polar equation into a rectangular equation. Okay, because we did so much in example 2, we did more than what was required in example 2. This example 3 is just going to be so easy for you guys. All right, so just like before in example 2, to convert this r equals 3 divided by 1 minus sine of theta to rectangular, we would cross multiply. You can make it over 1, cross multiply. So that would be r minus r sine theta equals 3. Now, just to double check, okay, you want to find your e value and then write somewhere on the side, especially if this is a test question, that it's a parabola. The reason is that when you are converting it back to rectangular, if it's a parabola, only one of the variables is being squared. Okay, so that's a mental check for you on a test or on your homework. All right, r is going to be the square root of x squared plus y squared. R sine of theta is going to be y equals to 3. Now move the y to the right before we square both sides. That would be 3 plus y. Now we would square both sides. So that would be x squared plus y squared equals, FOIL this out slowly and correctly, that would be 9 here. This is going to be y squared. In the middle, you're going to have 6y. Well, y squared and y squared, we are going to cancel that out. Now, let's see if we can put this in standard form. X squared equals, take out the 6, and then y plus, if you take out a 6, it's 9 over 6 in here, but 9 over 6, reduce that to 3 over 2. So this is the standard form of your polar. Now, as you can see, only one of the variables is square, so it is definitely a parabola. And you know it's a parabola because then you know you did it right. Okay, so check that off. And I feel like we did something like this already. Oh, look, that's the same thing as example 2b. Okay, except the 2b, I gave you it in cosecant. But look, once it's converted out to sine, it's the same thing. All right. Okay, now let's find the e value. Okay, to find the e value, what you want to do is divide both sides by this, because it has to be r equals in polar. Okay, so now we would get r equals 2 divided by 2 minus cosine of theta. This is so that we can check it. This is not in standard form, students, so make sure we multiply this by 1/2. What we multiply to the bottom, we would multiply to the top. So r equals, now the top is 1. This is now 1, and this is now a half. All right. Now e is a half because it's right here in front of cosine. Since e is a half, that's less than 1, so we know this is an ellipse. And we just want to check it, okay, to verify. So when we convert it into rectangular, you have the x is square, the y is square, and there's a plus sign in the middle. All right, let's see if that will help us check our algebraic work. All right, so now let's go and get a different pen here so we can do our work. Okay, now we don't, from the original, we do not need to cross multiply because it's already in a nice form for us, but we do want to distribute the r, so that will give us 2r minus r cosine of theta. So from here it's going to be 2 square root of x squared plus y squared, and r cosine of theta is just simply minus x. We do want to move the x to the left side before we square both sides to get rid of your radical. Now go ahead and square both sides just like that. This is 4 plus 4x plus x squared. This will give us 4 times the quantity of x squared plus y squared. Distribute that out on the right side. I'm just going to copy the left side back. This is going to be 4x squared plus 4y squared. Okay, let's try to combine like terms and then try to see if we can complete the square. So 4 equals, I'm going to move all of the x's and the x squared to the right side. Okay, move that over and move that over. So if we move the x squared over, we would now have 3x squared. If we move the 4x over, it's now minus 4x plus a blank space. Drop down your 4y squared. Now we can't technically complete the square unless the 3's factor out. So let's factor the 3. Okay, we don't need to complete the square for the y. We're just going to copy that straight up. So this is x squared. We take out a 3, so this is now 4/3 x plus a blank space. And remember, we want to do half of 4/3. Okay, half of 4/3. That means we're going to take 4/3 times a half. So reduce that. We're going to get 2/3. Okay, so half of 4/3 is 2/3, and we want to square it. So that's going to be 4/9, and that goes right here, 4/9. Well, we add it to one side. We got to go and add it to this side, 4/9. But this 4/3 is being multiplied by this 3, so we want to multiply this by 3 as well. Okay. So now I'm going to go down here since I want to save this to see what we need for later. So we got 3, reduce that down to 4/3 plus 4 equals 3 times, let's factor this out, x minus. Remember when we took a half? Whenever you take a half, that's right there. We're going to need it for factoring, and that goes right here, just like that. And then plus 4y squared. Okay, so common denominator is now 3. This becomes a 12. So that's 16/3. So 16/3 equals 3 times x minus 2/3 squared plus 4y squared. Now we have to make sure it equals to 0. So what we want to do is divide each and every term by 16/3, just like that. Okay. All right. So cancel, cancel. That will give us a 1, which is what we want. 1 equals. Now, as you can see, if you know how to do this pretty quickly, you can just go straight there. To get rid of that, I want to multiply by 1/3. To get rid of the 4, here we multiply by 1/4, just like that. So that would give us x minus 2/3 quantity square over 16/9. Leave it. And then plus y squared all over. We can reduce this right here. That's a 1, that's a 4, so that's 4/3. All right, so that's our rectangular form, and leave it in that format, because that is your standard form of our ellipse. Now let's quickly check, okay, a couple of things. Okay, do we have both x and y squared? Yes, so we know it's being closer to an ellipse, and there's a plus sign in the middle. So we have two variables square and a plus sign in the middle, so we know it's an ellipse, which matches our E value. Example 4. Find a polar equation of the conic. It has a focus at the pole. Now E is 2/3, and the directrix is parallel to the pole axis 3 units above the pole. Okay, so since E is less than 1, we know that this is an ellipse. Okay, so we know this is an ellipse. Since we know it's an ellipse, it also tells you that this directrix is parallel to the polar axis and 3 units above the pole. So we know P is 3. Our equation is R equals E times P divided by 1 plus E times sine of theta. Now the reason we know sine of theta is because of the directrix. The directrix is parallel to the polar axis. Okay, so if you don't remember that, we want to go back up. Here we go. If the directrix is parallel to the polar axis, okay, then we want to use sine. Okay. All right, so here we go. Well, we know what P is. Okay. So, and we know what E is. Let's try to plug some values in. R equals, E is 2/3, P is 3, so that's on the numerator. Then we have 1 plus E, again, is 2/3 times sine of theta. Then from here, we just have to get rid of the fractions or simplify that out, okay? So we got 2/3 times 3. That will leave me a 2 on the top, which is a nice number. On the bottom, though, okay, we want to get rid of this fraction, okay? So that way we're consistent with E not being any fractions right there. So that's easy enough. We're just going to go multiply each and every term by 3. So to get rid of fractions, we multiply the common denominator. When you multiply to the top, you multiply to the bottom. So I believe this will do it. So 2 times 3 is 6 divided by 3 plus 2 sine of theta. And this is as far as you can go. So right now, that has no fraction, which is normally what we want, okay? And that's the end of this note.